Hey guys, good morning. I had a couple questions come in about simplifying radicals. I made another video about it, so if you didn't watch that one, please watch that one first because it might explain quite a few things. I just wanted to go over a couple different examples of things you might see. Um, what you really want to be able to do by the end of this is put things in simplest radical form. And what that is you can think of it, it's like reducing fractions for radicals, okay? So again, a radical is just, and for right now, it's just a square root. It will be other things later. Um, but if I said, you know, radical 9, square root of 9, well, we know that that's positive or negative 3, right? We should know that. And for right now, if you even just say 3, that's really okay. But for us, there's, that's, negative 3 times negative 3 makes 9, and positive 3 times positive 3 makes 9, okay? Um, but an overwhelming majority of numbers, right? And it's tricky because there's infinity numbers of both, but that's a more advanced math problem. Is what happens if I said, what's the square root of 6? Well, there is no square root of 6. Well, I mean, not integer-wise anyway, right? There is a square root of 6. There are two numbers that multiply by themselves make 6, okay? So we talked about, a couple ways you can get around this, right? You break out your calculator, you press 6, you press the square root button, and you're going to get this irrational number right here, right? But for some numbers, not all numbers, like 6, that's it. That's all you can do. For some numbers, what we can do is we can simplify them. In other words, we can almost reduce them. It's not reducing, but well, let's think about it that way. What if I said radical 27? Well, if I said, hey, what's the square root of 27? I'm going to put in 27, take the square root, and I'm going to get this number, 5.196152422706632, and it just goes on and on and on and on. But we know our times tables, right? We talked about 9. 9 is a perfect square, and 9 does go into 27. So one of the things you can do is you are allowed to split this into factors. I can say this is radical 9 times radical 3. That is allowed. That is a legal move. Hold on, if I can find rabbit email tree. Oh my God. If I did radical 27, it is this number. And if I do radical 3 times radical 9, they do get the same thing. It is the same thing. So this is a legal move. You are allowed to do this. And what's the benefit of doing this is that I know the square root of 9. I know the square root of 9 is 3, right? Or negative 3, but we're not really concerned about that right now. 3, and then this can stay as radical 3. So if I said, hey, what's this in simplest radical form? It is this, okay? So all you really want to do is find one of those perfect squares that goes into your number. If no perfect squares go into it, then that's it. That's as simple as it gets. But for most numbers, not for most numbers, but for a lot of numbers, you can put it in a simpler form, okay? So it really comes down to factoring and knowing your perfect squares, right? If you can factor a perfect square, then you can go ahead and you can have a pretty good shot at this. So let's go over a few more, and then I'll kind of set you guys loose. I'll talk about why we are not really all that concerned about those negative numbers. Let's go radical 12. Radical 12 is not a perfect square, right? We know that 9 is a perfect square, and then our next perfect square after 9 is 16, right? So this is kind of in the middle of 9 and 16, right? So again, what are your factors of 12? Okay, more specifically, we could say 6 and 2, but that doesn't really help us because 6 and 2 aren't perfect squares. But we do know that 4 is a perfect square, right? 2 times 2 makes 4. And 4 times 3 makes 12. Well, the square root of 4 is 2, and radical 3 is just radical 3. So we can leave it just like that. And again, if you want to check it, what you do is you go to your calculator, you put in radical 12, and you're going to find out it's whatever nasty number it is, and you can put in the second time, you can say 2 radical 3 and make sure you get out that same nasty number, okay? So yeah, again, things like this will come in handy. They'll will be a little more useful. The reason we're not really concerned about the negative, right? So we said that square root of 4 could be positive or negative too, right? Well, we don't actually know what the square root of 3 is yet, right? Like we know that could be positive or negative, right? So since the square root of 3 can be positive or negative, when I multiply it times a positive number, that will take care of my positive negative sign. So really, kind of long story short, is until you get rid of all your square roots, there's no need to say the positive or negative sign because this radical includes those positive or negative, okay? All right, let's go over a few more and then go over some more kind of advanced examples of a couple things you might run into, okay? So if I said, let's do radical 18, let's do radical 125, radical 45, and radical 72. All right, we're big on the nines times tables here, okay? So again, 18 is not a perfect square, but what's a perfect square that goes in 18? Now think about your factors of 18, okay? And you don't want to use 6 and 3. What you want to use is 9 and 2. Do yourself a favor and write your perfect square first, okay? What's square root of 9? 3. Okay? 125. Again, I know you're thinking big number, but again, 25, right? That's $1.25 if you grew up in a different generation. Square root of 25 times 5. 25 times 5 is 125, right? What's the square root of 25? 5. 45, right? What are your perfect squares? Well, radical 9. Right? 9 times 5 makes 45. What's the square root of 9? 3. Okay. Now, for this one, I'm going to show you guys how you can get into just a little tiny bit of trouble here. I know you guys are thinking, what? 9 times 8, right? And square root of 9 is 3, 3 radical 8, and we are done, right? The problem is, what happened to radical 4 times radical 2, right? There's another perfect square in 8, so this becomes 3 times 2 times 2, which is 6 radical 2. So watch your last number for here. Prime number, prime number, prime number 8. Just watch out because there is a perfect square that goes into 8. Why does this happen? Again, there was a bigger perfect square that went into 72, right? It was actually 36 times 2. Right? 36 times 2 makes 72, which is 6 radical 2, which is what we got. So just be careful. Just watch the numbers, okay? And if you watch my other video, there's some patterns you can look out for. But again, if not, just make sure you're checking that radical when you're done to make sure. Sometimes you're going to have to whittle it down and start with a bigger number and make it smaller and smaller and smaller. Okay? The only other thing you're going to see in your questions today is that they're going to throw a number out in front. You just need to multiply by the number out front. Okay? So if I said this, if I said 4 times radical 12. Okay, all that means is 4 times radical 12, right? So what do we say? 4 radical 4 radical 3, right? 4 times 3 makes 12. 4 times 2 radical 3, and that 4 times 2 is going to be 8 radical 3. So all you really need to do is do what you were doing here and multiply by that number on the outside, okay? So if I said 3 radical 75, what is that? That's 3 times the square root of 25 times the square root of 3. 3 times 5 radical 3. Done. Okay, and 5 radical 27. Again, what were my perfect squares that went into 27? Radical 9 and radical 3. Right, 3 times 9 makes 27. 5 times 3 times radical 3, and this would be 15 radical 3. Okay, so like I said, hopefully that clears everything up for you guys. We'll start talking about what this means for us with some variables tomorrow, and then we'll introduce the imaginary number probably on Wednesday or Thursday. Okay, well, I hope this helped, and I'll talk to you guys soon. Thanks.